The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
We're going to be doing question number 2. And this is the fall 2010 version. Okay. Question number 2 states that the ball shown of weight 150 newtons is suspended on a string AB and rests against a frictionless vertical wall. The string makes an angle of 30 degrees with the wall, and the ball presses against the wall with a force of what? Okay, so I'm going to draw as always, you always need to draw the figure. It gives you a figure on the test, but you're going to need to draw the figure on your own and mess with it. So here's the wall, here's the connection, here's the ball, A, B, C for center. The figure on the test doesn't have this, but I'm going to make things easier. Okay? And 30 degrees. That's the 30 degrees that we're talking about. So we're asking, what is the force that the ball has on the wall? Okay? What is that force? So, what we're going to need to do is figure out all the different forces that are going on here. Excuse the bad drawing. So, as always, you have mg, the force of gravity pulling down on the ball. Now, if you only had this force, then it would be falling. So, to counteract it, you have this tension T going this way. Okay? It's acting on the center of the ball. So this is at an angle. So to make things easier, because it's at an angle of 30 degrees, let's change it up so that we have the horizontal and vertical aspects of the tension in different magnitudes, different directions. We have the horizontal and vertical. So the horizontal is going to be, here's the angle 30, it's the opposite of it, so we're going to have T sine 30 because of SOHCAHTOA. Don't be afraid to use this. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Don't be afraid to always write this down. It helps me out constantly, and I'm a tutor, so I should be knowing this, but I still write it down. Then you have T cosine of 30 going up. Alright? So these are the forces that we have acting on this ball. We have 1, 2, 3. We have 2 vertical forces and 1 horizontal. In reality, we also have the wall pushing against the ball, which is a normal force, but we're not worried about that really. So okay, we have 4 forces and they all oppose each other. So T cosine of 30 opposes mg, T sine of 30 opposes the normal force of the wall. Because this ball is not moving, that means that we have to make all these forces equal to each other if they're opposing each other. So that means that we know that T cosine of 30 is equal to mg, force of gravity. That's the force of gravity. So T cosine of 30 is equal to mg. That means, and we're given that, what else? What is the information that we're given? All shown. We know that mg is a weight of 150 newtons. Okay? So, we know that T cosine of 30 is equal to 150 newtons. Right? Then what do we do from let's try and find t. So divide everything by cosine of 30. So that crisscross cancel out with that, and this is divided by cosine of 30. That means that we have t is equal to 173.2 newtons. So this magnitude is equal to 173.2 newtons going diagonally. Alright? Now, so we have this variable t, and we're looking for how much force is going against the wall. That means all we gotta do is plug it in here. Because we know what sine of 30 is. So t, so then we go from here to here, t sine of 30 is equal to 86.6 newtons, which is about equal to 87 newtons. Pretty quick and painless if you draw it out and make things clear. If you don't, then it can become tricky and you don't really know what you're doing. 87 newtons is the correct answer.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.